Okay, all right, so we are starting packet 2. So we're gonna just try to get through homework 1 the best that we can. What I have found is that the class sort of divides at this point into students who are really fantastic at roots and radicals. I don't want to just call them square roots because we do a lot of cubed roots too. And then the other side of the class that literally cannot do them. They just can't do them. So, and it happens every year. So I think there's some kind of disconnect, maybe in middle school or wherever it is that you first learn roots, that either you get it or you don't. And if you don't, no one has ever come back and picked you up and helped you get through it for some reason. And so you kind of skated by still not being real sure about a root. So we're gonna all learn roots. Okay, I'm coming back for you and we're gonna figure this out. Okay, so first of all, we have to know what it is I'm talking about. So we need the little part. So that's where this little guy comes into play, but he's so teeny tiny. So I'm gonna write him over so he's bigger. Okay, so we call that a root or a radical. Either way, it's the same thing, okay? The little n that sits on this little kickstand, that is called your index. And that just tells you what kind of root it is. That's all. So if you kind of look down here on C, see how there's a little 3 on that square root of -10? That means that's a third root. That's a cubed root, okay? Now look at these others though. They don't have anybody on their little kickstand. So how do we know what root they are? What if you don't see a number at all? It's going to be a square root, okay? We had some people in the Tuesday, Thursday class that thought it meant there was a 1. Like if you don't see an exponent, you know, you think it's a 1. Well, and it is. But with a root, there aren't any first roots. So if you don't see anything, that means it's a square root, okay? So if there's no index, then that means it's a 2, okay? That means it's a 2 if it's just blank. Looks a little blurry to me, okay. All right, then the guy that's underneath the little kickstand that you're taking the root of, he's called the radicand. So I use that word a lot, radicand. So when you hear that, that's just the stuff that we're taking the root of, okay? And then this little kickstand guy that you see here, sometimes you see it with the little kickstand, sometimes you don't. You know, it varies. However you want to write it is fine with me, as long as you know that you're taking the root of something. So that is either called a radical or a root symbol. Doesn't matter to me which one you call it. I'm probably going to end up calling it both and really confusing you and switching back and forth. But either way, that's fine, okay? All right, so everybody think they got the parts handled, radicand, index, and then you just got the little radical part. All right, now before we really get into exactly what it means to take a root, let's talk about what if the radicand, what if the stuff inside is negative? Because that's important. So sometimes it's okay if it's negative and sometimes it's not. And the way that you know that is by looking at the index, okay? The index determines if that negative radicand is okay or not. If you have an even root, and I should have said even index, sorry, that's me again doing some weird language there. If your index is even, meaning it's a square root or a fourth root or a sixth root or some kind of, you know, any even root, and you have a negative radicand inside, we have a problem. That's when the problem occurs. So when the stuff inside is negative, but you have an even index, okay, what that results in is an imaginary number. That's when you get the little I, the little imaginary number. Now we're going to go into depth and deal with I's, but for right now, for this section, when you see that situation, you're just going to say not a real number. That's what you're going to put, okay? You're just going to put not a real number. Then later on, we'll start figuring out what to do with it, okay? So for example, look at this little square root of -16. So it's a square root because your index is 2, it's not there. You have an odd Be gracious. You have a negative radicand, right? So the answer would be not a real number, okay? Not a real number. And we have to think about why this is for a minute. So remember, when you're taking a square root, so your index is 2, really what they're saying, they're asking you is what number can you multiply by itself twice to get the radicand? That's what they're really saying. So what number can I multiply by itself twice to get negative 16? Well, if I multiply 4 by itself twice, I get positive 16. Well, what if I try negative 4? If I multiply negative 4 by itself twice, I still get positive 16. There is no way for me to take a number and multiply it by itself twice and get negative 16. It's just not possible. That's where the little I comes in. And I have a lot of students that say, why do we have imaginary numbers if they don't exist? Well, that's part of engineering. So if you're thinking at all of going into engineering, that's there are certain applications where you need imaginary numbers to make your equations work out, where you need imaginary numbers to get where you need to be with some of these formulas. And so it provides a place, because maybe you need a negative 16, but truthfully, real number wise, it's not possible. So that's why we put not a real number, okay? So if you're looking at A, B, C, D, E, F, yeah, A, B, C, D, E, and F, one of these is not a real number. So that would be like in my math lab question, and you would just have to click on the one that's not real. So be careful. I have some tricky ones in there to try to fool you. But if you look at A and D, even though D looks scary, these are fine, right? You can tell that these are real numbers. I'm just going to go put a little check like, yeah, you're real. Because they're positive radicands, right? I don't see any negatives happening, so I'm not worried about them. Now, if I look at B and E, I do see a negative, but where's my negative? Outside, right? He's not inside the radicand. So it's like having a -1 multiplied by your root, which is fine. So these are real numbers, okay? Those are real numbers because the negative's not underneath. Okay, now we get to the trickies. C and F, they both have a negative radicand. One of them is real and one of them isn't. And what it boils down to is the index, because remember, you're not a real number if your index is even. So which one is not a real number? F. F is not a real number because look, here my index is odd. He's a cubed root. So as it turns out, you can have a negative radicand with a cubed root. That's perfectly fine. That is a real number, okay? And let's think about why that is. Okay, so remember, your index tells you how many times do I multiply a number by itself to get the radicand. So for this one, for square root of -16, I would have to multiply a number by itself twice to get -16. And we proved that's not possible. There's no way to do that. All right, let's try this little guy down here. What if I want the cubed root of -8? Okay, cubed root means I have to find a number that I can multiply by itself 3 times, because my index is 3, to get -8. Just so happens that's going to be -2. Because if I do -2 times -2 times -2, same number by itself 3 times, what do I get? -8. This gives me +4. This gives me a -8. So a cubed root can have a negative index. That is so wrong. A cubed root can have a negative radicand. That's perfectly fine, okay? So odd index, negative radicand, you're good to go. Even index, negative radicand, not a real number, okay? So make sure that you can see the difference there. Is everybody okay with that, and why that is and why it isn't and all that good stuff? Okay, we're gonna do more of these later. All right, this is just a little helpful hint, a little trick here to kind of help you with some of the problems. So, and we're going to go into why this is later, but for right now, it's just kind of a little trick you can remember. If they ask you for a root and your radicand has an exponent on it, and that exponent is the same as the index, everything kind of cancels around it. And you're just left with the base, and that's it. So in this case, because it's the cubed root of 4 cubed, the index and the exponent are the same. They're going to cancel. You pop that little kickstand right off, take that root right off, and your answer is 4. Okay. Let's say that you had the 5th root of 2 to the 5th. Okay. A lot of students, their first instinct is to take 2 and to go ahead and raise it to the 5th power, you know, and fix that, and then try to take the 5th root. You can do that. You'll get the same answer. It's just you're going the really long way. Okay. So because these match, I'm just going to cancel them, take off my radical sign, and my answer is 2. Okay. Just a little to help you go through those a little faster on my math lab. Okay, so now we're going to simplify radicals. That's all we're going to do for the rest of this section. We're going to simplify the heck out of them. I mean, wait till you turn the page. There's like, that's all we do. Okay, so first of all, to deal with negatives, if you have a negative radicand and your index is even, what are you going to write? Not a real number, right? Not a real number. Done. Okay. If your index is odd, one way to handle it is just move that negative to the outside. And then you can always take the root of it. So if I came back up here to my cubed root of -8, I could think of what number multiplies by itself 3 times to give you -8. You're going to get -2. Or the minute I see this, I could move that negative right to the outside and leave what's under positive. This is like multiplying it by a -1. My answer is going to be negative. And then the cubed root of +8 is also 2. So you're going to get the same thing. You're going to get -2 either way. It's just another way to think about it if you like that better. Okay, so again, some students are so super good at simplifying radicals. Like they just totally get it. And if you get it, all I want is the answer. So give me the answer. If you need a little help, like where did that come from? Then here's your help. Works every time. It's super easy. It's kind of fun. And this will get you through it, okay? So if you need to simplify a radical and you don't know anything about this radicand, you're going to draw a factor tree, okay? So we're going to draw a factor tree. We're going to go through them together, do a bunch of them. Oops, I got a little carried away. Okay. And we're going to group the numbers by the index. Again, when you try to put math steps into words, it gets super complicated, so don't get hung up on this. We're going to do a bunch of examples. For grouped factors, you're going to take one of each outside the radical symbol. Okay, you're going to take one of each outside the radical symbol. For non-grouped factors, all of them stay under the radical sign. Okay, so that's what we're going to do, is practicing that way. Okay, now we're also going to have variables or letters involved. We'll come back and go over that little rule once we actually see some letters, because it's going to be, you know, another page from now. All right, before we flip over, let's talk about a few square roots and cubed roots that really would help you if you remember these, because it'll make your life so much easier. So remember, square roots, because that's an index of 2, that means the same number multiplied by itself twice to get your radicand. So what's the square root of 1? 1. It turns out that any root of 1 is 1. The cubed root, the 23rd root, the 100th root of 1 is just 1, okay? All right, what about square root of 4? 2, you guys know that, so that means 2 times 2 is gonna give you 4. All right, so I'm just gonna kind of write this over here. What about square root of 9? That would be 3, right? Because 3 squared is 9. So I just want to make sure that you guys see this relationship. So if you take a number and raise it to the index, that's the answer of the radicand. Take the number, raise it to the index, that's the number of the radicand, right? So there's a relationship between a squaring something and a square root. They're linked together. Okay, what about 16? 4, good, because 4 squared is 16. Let's see, I'm gonna just stick this, well, I'll stick it over here. Okay, we know 25 is 5, right? And we know 36 is 6. Good old 49 is 7. 64, we're gonna come back to him. 64 is super special. And we're gonna come back and talk about him in a minute, why he's so special. Okay, 81 would be 9. Okay, and now there's really 4 more that will make your life easier if you just remember these 4 more. So square root of 100 is 10. Okay, what about 121? 11, good. So that's one that will really help you if you can kind of remember that. 144, 12, and then good old 169, which is 13. And then actually the square root of 196, if you just flip these next 2 numbers, is 14. So that's kind of handy to remember sometime. But you should all have a calculator with a square root on it, right? So you should all be able to take your radicand, your 121, hit your square root button, and get your answer, right? Easy enough. You should all have that. Okay, what some students are not quite familiar with are cubed roots. So we want to make sure that you at least know the basic cubed roots. We don't go too high with cubed roots. We really only go up to 5. That's really all that you'll need to remember. I'm going to just, let's see, I'll squeeze them over here. Okay, so what's the cubed root of 1? 1, right? Because any root of 1 is 1. Okay, what's the cubed root of 8? 2, because remember 2 cubed is 8. Remember your little relationship there. So if it's a cubed root, then what number can you cube to get the radicand? All right, what about 27, cubed root of 27? That's your 3, because 3 times 3 times 3 is 27. All right, I told you before that 64 was special. All right, what's the cubed root of 64? That's going to be 4, because 4 cubed is 64. Now, why is 64 special? Because it's one of a very exclusive club that has a perfect square root and a perfect cubed root. Just a little math fun fact for you, if you want to know. So a lot of times students will see 64 under a radical and they'll automatically put 8, but check your index because it could be the cubed root. In that case, it's 4. All right, and then the last one that comes up a lot is the cubed root of 125, which is 5, because that's 5 cubed equals 125, okay? Now, your calculator should also do a cubed root, and you want to make sure you know how to do that. Every calculator is different, so you want to really practice that. There's a lot of cubed roots out there, big giant ones that are perfect cubed roots that you may not realize. So depending on what calculator you have, I'm going to just flip this over because I need some more space, but you may have a beautiful little cubed root sign. And if you do, then you can say just put in an 8 and then hit your cubed root and it's going to give you 2, and that's fantastic. Okay, sometimes you get calculators that skip the cubed root and they do something like this, which is perfectly fine too, but you may see that. This means it will do any root, which is great that it will take any root, but look at your index. It means you have to put in the index first. So if you have this button rather than a cubed root, what you're going to have to do first, if we're using this problem, is tell it what index you want, so 3, then hit the button telling it we're taking a root, then put in your radicand. That should give you 2. Okay, if it doesn't, if you have something else that's weird, Shalondra, did yours do it?
Mine was the first option.
Oh, perfect. Okay, so if yours doesn't and you really can't quite get it to work, I know I can get it. It's just that sometimes they do things out of order. So just let me know if anybody's struggling with their calculator. But yeah, this is fantastic if you have that option. If you don't have this one, it's no big deal. It's just you're going to have to tell it what index first, then this, then the radicand, then enter. So boom, 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 enter, okay, to try to do that. All right, everybody okay with that? All right. Brianna, does yours have one or the other? Okay, all right. Okay, so now look at this. So pages 2 and 3, that's all that's left of this this section. But look, all we are doing is taking roots. So lots and lots and lots of roots. Okay, we're going to start out really simple, and then when we get down here to square root of 72, that's when we're going to have to start dealing with some factor trees. Okay, so these up here, we're just going over some rules, making sure that you guys remember your rules. So what's the square root of 9? 3. There's your answer. Okay, you can always put that in your calculator if you forget. All right, now I'm looking at my next one and I see a negative radicand. So I'm going to stop for a minute and look at my index. If my index is even, not a real number. My index is odd, I'm okay. I can keep going. So my index is odd, so I can keep going. What's going to be the cubed root of -1? -1. Now you can always remember, if you need another step in here, you can always take that negative and pull it right out front. And so all you're doing is taking the cubed root of +1, which you know is 1. Just don't forget to move that little negative along with it to the outside, okay? He comes along with it. But all I'm grading on is -1. So if you go right to it, that's fine. You can even put that in your calculator and it'll come out -1. All right, now look at these two. Let's compare them. We have an even index, so we have a square root. This one has a negative radicand, this one has a negative outside. One of these is a real number and one of them isn't. Okay, let's start with this guy. What's the answer to this guy going to be? Not a real number. You can't have that negative radicand under there. Okay, we'll come back to what that would actually be. If you're comfortable with imaginary, you know that the actual answer is going to be 2i, but that's like in another section. Okay, this guy over here, what's my final answer going to be for this guy? -2. I've got a negative hanging around out front, so let him hang. There he is. And then the square root of 4 is 2. Perfect. Okay. All right, same situation for these next two, but I have an odd index. So since my index is odd, I better have an answer for both. Okay, and let's look at what these two answers are going to be. Okay, so if you want to, you can go right to your answer for this one. If you want to move your negative outside, you can do that. Okay, just add in another step. What's the cubed root of 64? 4. So your answer is -4. All right, just so happens this guy's negative is outside. So I'm going to just write him over. We said cubed root of 64, 4. Look at that, they have the same answer. So not only are you able to take an odd index for a negative radicand, it's going to be the same answer whether the negative was inside or outside. Okay, so pretty easy for that one. All right, now let's get into some that aren't quite so easy. So everything we have done so far has been one of those nice, easy ones. We call them perfects. A perfect square, a perfect cubed root. It's been a perfect radical. That means it comes out as a whole number. With radicals, you cannot use decimals. So if you look at this next one and you go, I don't know, I'm gonna put it in my calculator, and you put the square root of 72 in your calculator, you're gonna get a decimal. Do not write that decimal down, okay? We don't want it. You have to have a perfectly simplified root there. So he's not a perfect root. He doesn't have, you know, there's not a single number we can multiply by itself to get a 72. So if you know and you're comfortable with putting the answer to this, you go right ahead. That's all that I care about. If you need another way to get it, let's do a factor tree. Okay, so what I mean by that is I'm going to take my number and I'm going to split it. And I'm going to say, give me any two numbers that multiply to give you 72. I don't care what they are.
36 and 2.
Look at 36 and 2. Okay. Smarty Pants Reese over here. Okay, I'm also going to do 8 and 9 because I think you're the only person in America probably that said 36 and 2. That's very good. maybe Chandra did too. Okay. All right. So I'm going to just show you that you can pick any two numbers you want. Okay. She's good at roots. That's why she picked that. All right. So now I'm going to keep going and I'm going to break down each one of those numbers until I only have prime numbers. So this 36.
We're going to be doing a fire alarm test. You may hear alarm, you may not. Just
Of course you are. Okay. Thank you, Billy.
Okay.
All right. How about that? Yeah, we don't actually ever leave the building. So we're not the high school where we all file out. We're like, I think that's real. It's probably not. Just let me know if you smell smoke. Okay. So 36 will break apart. I'm going to do 6 and 6. Okay. Now 2. Can I break apart 2 into anything? No, he's prime. So I'm just going to put him there. Now notice I keep putting dots between them, right? I keep putting dots there. That's because every branch, every level of my tree should multiply together to give me 72. Okay. Now 6, they're not prime. I got to keep going, right? So I'm going to keep going. He's going to be a 2 and a 3. This guy goes down to a 2 and a 3. And we already said 2 can't break apart, but you can't leave them behind. You got to bring them on down with you. So see how I kind of made a tree, like a little Christmas tree here? And remember, the key is the whole line, the whole branch should multiply together to give you 72. Now, let's go back and look at this one real quick, just in case you had chosen these numbers. All right, 8 breaks into 2 and 4. 9 breaks into 3 and 3. Okay. All right, 2 doesn't break down, but I'm going to bring them on down because you can't leave them behind. 4 breaks into a 2 and a 2. 3 doesn't break down. 3 doesn't break down. Okay, so even if I had chosen these two numbers, look, the bottom row is exactly the same. They're out of order, they're a different order, but that doesn't matter. The point is, you are going to get the same numbers in your bottom branch, no matter which 2 you start with, okay? And they multiply back to give you 72. All right, so we get a factor tree. Now we're going to look at our index. It's a 2. We want groups of 2 numbers that are the same. If our index was 3, we will want groups of 3 numbers that are the same. So we have an index of 2. We want 2 numbers that are the same. Well, here's 2 2s. Okay. And here's 2 3s. Okay. If I had done it this way, here's 2 2s and here's 2 3s. Same thing. Okay. Everybody got that? Now, if you've grouped them, you're going to take one of them and put them outside the radical. So I have a group of 2, I'm going to take 1 2. I have a group of 3, I'm going to take 1 3. Then anybody not in a group goes under the radical. 2. I clean it up. 2 times 3 is 6. And my answer is 6 root of 2. Okay. So I know that seemed like, oh my gosh, I'll be here forever. Like I'll be 20 years old and still doing homework 1. I promise it goes really fast. We just did that slow. So factor tree it down. Make sure your bottom branch multiplies together to give you your radicand. If your index is 2, circle groups of 2 numbers that are the same. If it's 3, groups of 3 numbers that are the same. one of each group comes out front. Everybody who's not grouped goes under. And then you have your answer. Okay. All right. Let's try this next one. I'm going to put it over here. Okay. So 1,260. All right. I don't know, but I do know that since it has a 0 on the end, 126 times 10 will give me that. You can divide it by 2 in your calculator and see what it gives you, or 3 in your calculator, whatever you want to do. Just pick 2 numbers that multiply. All right, now I need to break up 126. Well, I'm going to divide it by 2. And I get 63. 2 and 63. All right, I need to divide 10. You can put 2 and 5. You can put 5 and 2. You can put it any order you want. Now keep in mind that every row has to multiply back to give you 1260. All right, so 2, he's prime. I can't break him down anymore. He comes along. What does 63 break down to? 7 and 9, right? I'll bring along 2 and I'll bring along 5. There we go. All right. Now, okay, I'm almost done, except that 9 can be broken down into 3 and 3. Now, the biggest mistake students make is they don't want to bring down these other prime numbers. They just want to bring down the 3 and the 3. You can't do that because the whole branch has to multiply back to give you 1260. That's your checkpoint. Do they multiply back to give you 1260? All right, now everybody's prime. I go back and look at my index, it's 2. I need groups of 2 numbers that are the same. Well, I have 2 2s and I have 2 3s. Okay, so one of each of the groups goes outside. Draw my route can. Everybody that's not in a group goes under. And I'm multiplying these guys together. So your final answer should be 6 root of 35. That's your answer for this one. Okay, does that make sense? So I'm not saying that you have to do that every time. You don't have to do it at all. But if you run across one of these that's just really monstrous and you can't figure it out, this works every single time. Okay, so we'll come back and do more of those in just a minute. Everybody okay on these 2 though? Any questions? I know it's strange. Okay. All right, let's look at this guy. So some of you have already looked at him and decided no, and you've just skipped ahead in your mind because it's a fraction and it's under a radical. But remember, just take it one step at a time. You can take the square root of the top and the square root of the bottom separately. You can kind of distribute that radical. So now what's my numerator going to be? 2. And my denominator? My answer is 2/5. Easy enough. Okay. All right, now let's look at this guy. Okay, so again, I have a negative hanging around out front, so the negative's going to come on through. I'm going to go ahead and put a cubed root in the top and a cubed root in the bottom. Okay, so in my answer, I'm going to have a negative. What's the cubed root of 1? 1. Okay, now I just have to figure out what's the cubed root of 343. Okay, so if you put 343 in your calculator and take the cubed root just to check it, it actually turns out to be 7. But I'll be honest with you, when I was going through this packet and did it, I didn't do that. I looked at 343 and thought, there is no way that that is anything perfect. So I did a factor tree for him. So let me just show you what that would look like just in case. So if I have 343, okay, so I played around in my calculator, I divided it by 2, I got a decimal. Divided it by 3, I got a decimal. I kept on going. Finally, when I divided it by 7, I came up with this. Okay, now from that point, most of you can figure out that it's the cubed root of 7, but let's keep going. So then I broke it on down. There's my factor tree. I looked at my index. My index was 3. So I need 3 numbers that are the same. It's the whole bottom branch. One of them comes outside, everybody else goes under, but there's nobody else to go under. So guess what our answer is? 7. So that's how it's going to work out if it ends up being a perfect square or a cube or something as you're going through it. Okay, does that make sense? Okay, and then, all right, we have 125. We have the square root and we have the cubed root. So turns out a square root of 125, is that perfect? No, he's not perfect. So what are we going to do to him? Well, you can always factor tree him. I know 5 goes into him, so if I divide him by 5, I get 5 and 25. All right, 5 is prime, so I'm going to bring him down. Nobody goes into 5 except himself and 1. 25 breaks up into 5s. Okay, so if I multiply the whole bottom branch, I come back to 125, so I know I'm good. All right, so for this problem right here, my index is 2. I only want numbers, 2 numbers that are the same. That's what I want for square root. So I take one of the group out. Everybody not in a group goes under. And there's your answer. Okay. Now, this next one wants the cubed root. Well, he was one of our special ones, right? So the cubed root of 125 is actually 5. Now, if you go back to your little factor tree, though, I want groups of 3. So here's a whole group of 3. Put one of them out. There's nobody left to go under. He's 5. Okay. All right. Turn them over here. Go a little bit more. Okay, one more with just a number, and then we're going to get into some letters. So then we got to figure out, what do we do when we include letters? Because we'll be fine with the coefficients, negative 32, negative 216, negative 243. We'll be fantastic. The problem is, what do we do with all those letters? But first, let's look at this one. Anybody know right off the top of their head what this answer is going to be? Not a real number. I fooled you with the 4th index. Remember, a negative radicand and an even index is not a real number. So kind of keep that in mind. My math hub loves to sprinkle those in. Okay, let's talk about letters here. So before we get to the little quick and dirty shortcut, let's make sure we all know what's happening underneath there, because we can kind of apply this to our factor tree situation. So x to the 10th means how many x's do we have? We have 10. Now you certainly don't have to write 10 x's unless you just want to, but I just want to show you this. 6, 7, 8, 9, 10. Okay, so we have 10 x's under there. All right, I have an index of 2. So according to our little method, I need to make groups of 2 of the same. Okay, well, here's a group of 2. Here's a group of 2. Group of 2, group of 2, group of 2. Okay. All right. According to our method, I take one of each group, one out of each group. So I'm going to take an x out of this group, an x out of this group, an x out of this group, an x out of this one, and an x out of this one. I don't have anybody that's not grouped. So I don't have anyone that's going underneath a root. Okay, now I have 5 x's. So what does that equal? X to the 5th, right? And that's my answer. That's my answer. Okay, so that's what's actually happening. You're doing it the same way that you're doing the numbers, okay? But look at some of these. Y to the 15th. Nobody wants to write 15 y's. So we got to have a quick and dirty trick, right? So here's your dirty, quick and dirty trick. You're going to take the exponent on your letter divided by the index. That's all we're doing. 10 divided by 2 gave you what? 5. Boom, you're done. That's what we're doing, okay? But I want you to know why we're doing it. So that's great if it's perfect, like x to the 5th. Look at our next little guy. Look at our next little guy. Okay, so let's look at what to do with him. Okay, this is, I promise the last time I'm gonna draw them out and circle them, but I just want you to see what happens when they're not perfect. Okay, so we have 5 x's according to this. All right, we have an index of 2, so we're doing groups of 2 that we're circling, okay? We're taking 1 out of each group, so x times x. That's who goes outside. He doesn't have anybody, so where does he go? Underneath. Clean this up, and our final answer is going to be x squared root of x, right? That's according to our rules. Everybody got good on that? How that worked? 1 of each group. If you're not in a group, you go outside. So how does that apply to our quick and dirty trick? Okay, the exponent, you're still going to do exponent divided by index, but then here's what you're going to do. The answer, or the quotient, is the exponent on letter outside. Okay, any remainder is the exponent on letter inside. That's the key. Now I wrote all that over on the beginning of the packet right here, but you know, again, it's not written really great, so sometimes it's really confusing, but it's back here at the beginning if you want it. Okay, so your remainder stays inside, your whole number answer goes outside. That's the key to remembering that. Okay, so let's try it on this guy here. All right, so if I take my exponent and I divide it by my index, it's not going to come out perfectly. I'm going to end up with 2 remainder 1, right? That's what I ended up with. The answer is on the outside, x squared. The remainder is on the inside. And there's your answer. Okay? So that's what's happening. Okay, now, sometimes, look at this little dude. There isn't anything you can really do. The cubed root of x. There's 1 x. I need groups of how many according to my index? 3. I can't do anything. If I try to divide, I've got 1 divided by 3. I'm not going to be able to do anything at all. So he's done. He's already simplified. So another little thing you want to remember is that if your exponent is less than your index, you're done. There's nothing you can do. You're done. Okay. All right. Let's try one more here, and then we'll stop right after this one because I don't want you guys to get too far ahead of the other class. You're already a little far ahead. Okay. So this one's actually going to turn out to be perfect, but let's see what we're going to do. So we're going to look at each individual part, just like you do with exponents when you're moving them and you're checking them all out. So first is 25. Can I take the square root of 25? Of course I can. 5. Perfect. Okay. Now, what would the square root of x to the 6th be? X to the 3rd, x3. Good. There's your answer. So let's talk about how we knew that. We know square root of 25 is 5. But here, I took the exponent divided by the index. It ended up being perfect with no remainder. So this answer was right here on the outside, and I didn't need a remainder. If I needed a remainder, let's say my remainder was 2, you would have square root of x squared inside. Right? He would go inside. Okay, we'll stop there and then we'll finish these last few on Monday. Okay?